Okay, so good afternoon, everyone, and welcome to this presentation of OTF Connects titled Using Math Moments to Multiply Math Skills. Today's episode is called Linear Relationships and Equations. Sorry for my French. As always, with Cal Pearce and John Orr. As I mentioned, this is already episode 7, so we are moving along. And for those of you who were with us last week, we did look at proportional relationships, and we are going to continue with our discovery of these math principles today. And as I said, with 179 registered teachers, I'm hoping to get about 60 people in the class. And we are at 34 right now. So let me just do the quick land acknowledgement that we usually do. We acknowledge that we are gathered in the territories of various indigenous people, and we further recognize their stewardship of these lands in which we live, learn, work, and play. And of course, since you are all, most of you repeat participants, you already know Cal and John very well. As I always say, they teach, they blog, they podcast, they do conferences and symposiums, including online, and they are with us today with this OTF Connects, this new OTF Connect session. So we are delighted to have them with us. If you want to learn more about them, just visit their blogs. Kyle has 2 blogs, tabintoteensmind.com and mathisvisual.com. And then John has also 2 blogs, one called MrOrisAGeek.com and the other one is mathbeforebed.com. So here we go, 6 minutes after 4, almost 40 people in the class. I'm expecting another 20. So Kyle and John, we can start, and let's go ahead with a new fantastic session. Thanks so much.
Awesome stuff. Thanks as always, Michelle, for your introduction, and we are super excited. I think we say that every time because we are super pumped to hang out with all of you in this session on making math moments so that we can multiply our math moments. And we are really excited to talk to you about, in this particular episode, this is episode 7. Is that 7? 7 out of 10. We are kicking along here. We've been going strong, and we've got only 3 more after this one to do. So super excited. Now we do this every kickoff to start our sessions. Is get yourself in the chat. Let us know where you're coming from. Let us know what you're teaching, what your role is. We've got lots of folks who are pre-service teachers. I think Ray from Queens. That's where I went, Ray, Teachers College at Queens. So awesome stuff there. And let us also know right now in the chat how many sessions out of the 7 you have been to. Give it to us. Put a number in there. Maybe this is your first. Maybe this is your 7th.
Oh, we got
Michelle. 7.
Teresa's been all 7. Michelle, George is. Oh, this is awesome. We are super excited here. And like John said, linear relations, proportional reasoning, and then that's so closely linked to linear relations. It's kind of like the gateway for secondary mathematics, and it begins in elementary, but there's a lot of I would say a lot of procedures that float around that that people don't necessarily have a really solid grounding in, especially when it comes to modeling. So today we're super excited to do that. John, I think we're going to get started by first off, let's talk a little bit about what it is that we're actually going to learn today. Let's get started with that. Let's go to our first one here. John, what are we hoping people are going to achieve?
This is, if you've been with all 7, and then you know that we've got a couple of these slides that are the same. We said this last week too. It's what we'll get is we want to spark your curiosity. We're going to use something that we've been referencing along the way here in all 7 episodes called the Curiosity Path, which is about sparking engagement so that we can get our students in and going. We've got to hook them in. So we want to be able to do that. We're going to do that with you too. We're going to spark your curiosity. And we definitely want to do that. Kyle, what else are we hoping to do here?
Yeah, again, committing a bit of a crime when it comes to sparking curiosity. We are going to tell you up front the concepts that we're going to be exploring. But again, in a math classroom, we're going to probably withhold. We're not going to get as specific as telling you about that specific concept. But we do want you to note that we are going to approach this conceptually. We're going to do this with a really low floor, and we're going to try to help emerge some of these ideas without using steps, rules, and procedures. And things are going to get harder, I think, for our participants, because you might remember or maybe have a recollection of how you did things when you were going through school, or maybe you are a secondary teacher and or an intermediate secondary teacher who is kind of stuck in this algorithm, steps and procedures. So we're going to try to help you sort of make amends with a little bit of the conceptual understanding behind it. And then John, finally, what's kind of like the overarching big idea, why we do what we do here?
This is the theme of the whole series, is to try to repair and strengthen your relationship with mathematics so that you can do that with your own students and help change the way your students are viewing mathematics. We've got so many people, hating mathematics, and we are looking to change that. In order to do that, we have to help you become comfortable with the actual math. So that's the focus of the whole series, is we're diving into the how proportions are now going to be related to linear relations. We definitely want to connect. We want to learn the math ourselves so that we can feel comfortable doing that with our students. Kyle, let's get going here. We got lots to talk about.
Absolutely. So today we're going to try to help leverage these math moments. And we want to, again, share that it isn't luck. These memorable math moments can be created. We shared this way earlier in maybe episode 1 and 2, but we want to come back to it. We want to make sure we keep reiterating that, we're going to build everything through this 3-part framework. And today we're going to get started with a little bit of a notice and wonder. So let's dive in here. We want to make sure we maximize the time, because today we're actually going to explore, as we did earlier in some of our previous sessions, we like the woolly worm race, we didn't get to share the entire unit. We only got to really look at day 1. So today we want to see if we can get a little further than day 1, which means we're going to be sharing some of that day, but then we're also going to be skipping over portions. So you're not getting the whole big picture, but we want to make sure we take you on this journey to help you make some connections so that you can sort of see where it begins and where it'll end up. Because one of the things that I think it can be really challenging as an educator is thinking about, okay, if I'm going to change how I'm teaching, I get what you're sharing with me during this webinar, but what about when we get to the 3 steps down the road? What's that going to look like? We want to try to help make that a little bit of that connection along a few of these bigger ideas. So today we're going to get started. We're going to start with the notice and wonder. John, tell them what they're going to do here. You get to choose today, John. Are they just going to explode the chat or are they going to do like a waterfall? How do you want to do it today?
I prefer not chat explosion when we are noticing and wondering. I like the trickle. I like the trickle when the notices and the wonders come in through the chat. So Kyle is going to, we've done this, I think, on every one of our sessions, is asked you to notice and wonder. This is us kind of following our curiosity path, kind of stepping into the task that we're going to be looking at here today. So we're going to ask you to notice and wonder in the chat. And that means you write down anything you notice, anything you wonder. Kyle's going to play a very short clip. And I think it's pretty short. And then you just type it in. You maybe play it twice. And you just type in anything you notice and anything you wonder, anything that comes to mind. It doesn't matter what it is. Let it free flow. And we will take a look at what's coming through the chat as he lets it go.
All right, let's test our keyboards out. Is everybody clear with that? Everyone's feeling good? Everyone's got that? Let's see. I want to make sure they're working. Okay, I don't know.
Are you there? Are you there? It's like I say that to my students all the time. Like, are you still there? Are you there, guys?
They are there. Oh, thank goodness they are there. Here we go. Let's give it a look. Hopefully you can hear this. John, can you hear it?
I can hear it.
All right, loud and clear. All right. Keep those coming. I'm going to play it one more time. John, feel free if you want to start, sort of sharing any of them as they're coming in here.
Let's wait a little bit to share, and we'll let some more thinking come in once you play that one more time.
Here we go.
Couple things coming in here. What's he saying? That's a common one.
That was definitely, I was curious about that. Definitely curious about that.
Ness says he's huge.
Oh, yeah, for sure.
Here's a wonder. How high did it go, Kyle? How high did it go? How far did it go? A notice here from Kathy says it looks strong. He looks strong. Kara says it's at its highest point. How high did it go? How high did it go? Someone else above that, before I started reading them, Churchill talks about there's something going on with the arc in a parabola. We've got how heavy is it? Is that put? I believe that's what you call that ball. Is it put? Or a shot. Sorry, it's a shot. You put the shot.
You put the shot somewhere.
You put the shot. Yeah. I got it wrong. We've got. Is he happy with the result? That's a nice wonder. Is this the Olympics? Denise wants to know. And then 20,21, but no further numbers. We see some numbers, but we're not seeing maybe what that means. Looks like it could be a world record. Churchill is wondering out loud here. Faye is wondering about his anxiety. He seems to be pretty amped up and going strong here. Ray says, I'm wondering about the velocity or the velocity formula. Lots of wonders here. A lot of high highs did it go, and how far did it go? How far did he throw it?
Let's get that down.
And one very first notice that came in here was a Polish Olympian. Kyle's typing away. Now, when I do this in my class, if we are not remote, because Kyle's kind of modeling it how we do this remotely. If I'm not remote, then I write these on the blackboard or my whiteboard, and I usually write their names right beside them just to keep them up there. And we leave those up. Like I try to put it somewhere in the room, like on my blackboard, but off to the side, maybe like if we're gonna do some thinking along the boards, I don't want to erase these because I love to keep them up as we go through the activity that we've very narrowly picked out here for you to do. We like to come back to these and go, okay, let's now answer a couple more of these. Like we're going to answer one or two now, but we can also answer more as we go through the actual activity. So one thing is like when those wonders come up, you can go back through and go to, you've got the name attached to it, like how high. And if you answered that with math through the activity that we are planning out, we're not telling you exactly where we're going here with what we're doing, but you can go back and say, let's say that was Ray, and we could say, hey, Ray, did we answer this? Are you satisfied with that answer? And it's kind of like bringing it back full circle to say like your voice counts here. And I think that goes a long way. Like it's a small detail that's often is overlooked, but it goes a long way when you build your culture of your math class to say, hey, voice counts, your thinking here, your wonders actually matter for what we do in this class.
And something else too, and I've been trying to be better at this lately. So I really tried today during my lesson that I did with this grade 7 and 8 class to really try to like frame out the context. So, what I used to do, and John and I always talk about the way that we used to try to engage students. And now what I realize is like story is one of the most like important aspects of sparking curiosity. So video can add something, an image can add something, but it's like the story, right? Like everyone's gathered around and listened to a good storyteller. So it's like, if I can get better at telling the story of the context, you can help to paint a picture that's even more vivid than what they saw in that video. So, you know, we tend to come to these noticings and wonderings, like John said, and we try to hit some of these. Like some people said, like, there's a shot. I agree. Someone had said it could be a world record. I'm not sure if it is the world record, but that's something I'm hoping we'll find out today. It's a Polish Olympian, and you're right, it is the Olympics. This is from Berlin in 2009. Sometimes students notice that, you know, they can tell like it's on the world stage here. And, you know, happy with the results. Someone was asking, or maybe it was a notice because he appeared to be very happy. Definitely looked like he was pretty amped up. But some of these others, I'm not sure if I know the answer to. Like, for example, in one class, students asked this question as well, which is like, how heavy is the shot? We took some time, we went to Google, we kind of like had them estimate, like, how heavy do you think it is? You know, and we kind of had a little bit of a discussion based on that student. But today, what I want to do is I want to set you up with like a different view. John, are you cool if I share like a different view of this shot put that was, I guess, the shot that was put from a different angle? Is that cool?
Let's go top down view.
Top down view. Okay. Is everybody ready to see top down view in the chat? Let us know if you're ready, because I'm ready. This is what this looked like top down. Here is the part or the spot that they're measuring the shot from. And after, when he gave this a good throw, it ended up right here. And it actually, some of the things that students might not know, and maybe you don't even know this, is that they measure from the first impact. So basically, wherever that ball hits first, that shot hits, we're going to measure there, kind of like long jump. Like a lot of students know that from like elementary school, you know, doing long jump and track, wherever that first imprint is. So there's that shot. And the question that you folks had for us, but it's also a question I have for you, is how far do you think he threw this shot? Now, first, I'm going to give you an opportunity here to throw out an estimate based on like whatever knowledge you're bringing to the table about shot put. So think about that for a second. Like for some of you, you may have thrown shot put as a sport. Like you might have been on a track team or something. So you might have like a good sense of how far, especially an Olympian, can throw a shot. Whereas some of you may not know anything about shot put. So you're really taking a bit of a stab in the dark. And what we want to see here is kind of like, what's our starting point? We're going to give you this opportunity. We could give you a low and high opportunity, but today we're going to keep like to the point. I'm wondering, like, throw out your best guess based on whatever knowledge you bring to the table about shot put. All right. So we're going to give you a moment here. John, are they sharing already, or do you want to
yet?
Do you want to waterfall this? How do you want to do it, John?
Yeah, let's
It's hard to decide. I know.
Yeah.
So many choices.
I'm thinking, I think we better at this time. I think what we'll do is right now, Kyle, let's not waterfall this one. Let's trickle. So waterfall is the shot explosion, but let's trickle this one. And then I think what we'll do is we'll think about what happens after this. I think I got a good idea for the next step.
Awesome. All right. So we'll give you just a tiny bit more time here, John, as they're trickling in here. Go ahead and throw some out. Like,
so here's what I was anticipating, Kyle. This is why I didn't want to go chat explosion yet, is because we've got some different backgrounds coming into here. Like somebody is saying, it's like 20 meters, 50 meters. Michelle is saying 22 meters. But then all of a sudden, I'm calling out Ray again. Ray says 50 feet. So it's like we're mixing up our units now. We've got 50 feet and meters, a lot of meters, obviously. I think meters is common, but a lot of that 1 foot in there, or that 150-foot estimate.
Give me some meters. Like, what were some meter estimates?
45 meters, 20 meters, 23 meters, a lot of 20-ish meters. There's 30, but then there's no units from Denise. It's like, is it 30 feet or is it 30 meters? I'm not sure because we've got multiple units happening in here. The 40 meters, 32 meters, 15 meters, Kyle. We've got a good selection across the board. 70 meters, I think, is the highest I have seen this estimate go.
Whoa. Okay. So we do have a bit of a problem because, like, I can't even put this on a number line necessarily because I've got this one over here. And John, it's interesting because when I do this with students as well, I'm sure you've seen this or noticed this as well, that like oftentimes students will use feet, especially here in Southwestern Ontario, where John and I are from, because we are so close to the US. We have like a really, you know, I feel like some Canadians don't think we're Canadian. US Americans don't think we're American. It's like we don't really fit in anywhere. But this poses a problem because I need some sort of common unit. So I'm wondering, what if I was to give you like a common unit that we could all work from?
Let's standardize this unit here. Let's standardize this unit.
All right. Now, this is a pretty old school system that they were using at the Olympics in Berlin. They actually, the officials would actually measure. They wouldn't measure with like a tape measure or anything like that. They didn't have lasers or anything. What they did is they actually used a measuring stick. But I want to be really specific here because this measuring stick that they used is not like a meter stick. And it's not a like a yardstick or any standard measuring tool. This is like, this official has this measuring stick and we don't know what the true length of it is. But what I can tell you is that this is to scale. So what you're seeing right here, this big number line and that stick right over there, they are to scale. And what we'd like you to now do is take this information and we'd like you to give us an estimate based on your spatial reasoning skills. How many of these measuring sticks? We're not going to do low or high because I think our range is going to be pretty tight as is because the quantity, like the number will be small. So yeah, let's go ahead and start getting some estimates down in measuring sticks. I'm really curious.
See, this is also a great moment, you know, with your class is if someone is going to talk about feet, now we're coming to the same measurement system by making this new estimate. And it's a nice way to kind of like use a non-standard measurement to kind of pull us all together and put us all on the same track. We were going all over the place before that. Kyle, a lot of 6s, a lot of 5s. Highest I've seen so far is a 7. Lowest I've seen is a 5. A lot of 6s.
Whoa.
He's drawn his number line.
Yeah. So if this is like 5, then like 7 maybe here. And like, it sounds like you've got kind of like a range.
Yeah, we're in that box right there.
We've got like lots of estimates between 5 and 7 in there. Interesting. Maybe some people have some other thoughts. If you're outside 5 or 7, go ahead and put that in the chat because we want to make sure we want to get like pretty accurate here on what your range actually is.
We don't have anybody outside 5 or 7.
No, we're feeling good. Okay.
In the chat.
Okay. All right. Let's keep rolling along here because I wonder if we can help you out with a little bit of information. I want to get a little more precise. What I'm going to do for you is I'm actually going to share something with you. I'm actually going to share. What am I going to share? Where are you? I'm going to tell you how many measuring sticks it was, and let's see who came close. Let's have a look at how many measuring sticks. It's not 1, it's not 2, 3, 4, 5, or even 6. It's actually,
6 and...
It's not 7 either. Huh. It's 6 measuring sticks, and the official actually had to pace out an additional 8 feet.
Now your head's blocking
Now-
that, by the way.
Oh, shoot.
There
There
you
it
go.
is. There it is. I think probably better. Here's what I would like you to do right now is I'd like you to take this newfound knowledge, and I wonder if you can update your estimate. This time, we're going to try to figure out how many feet do you think? How many feet long was this throw based on what you're seeing and based on using your spatial reasoning skills? Let's update our estimates just a little bit. Go ahead, do that now. And I'm going to be jotting it down on our page in just a moment. I just want to adjust something here so that I'm a little smaller and out of the way. All right. Anything coming in there, John?
Interesting stuff happening here. There's a lot of 68 feet. There's a 70 feet, 68 feet. Like, I'm wondering, where is that? Is that because we're saying each one is 10? I'm not sure. Oh, Lindsay's saying just guessing 10 feet each.
10 feet.
All right.
Each.
So there's a lot of 68s,
per stick, I'm
Kyle.
guessing, right? I'm guessing per stick.
Sarah says I guessed 10 each. So she's estimating that each stick is worth 10 feet. And
So
go ahead.
I wonder if I could model that if I was like, okay, so there's 1 jump of 10, 2, 3, 4, 5, 6 jumps of 10. And then plus this additional, is it 8 feet? I'm going to have to zoom out just a little bit here. Yeah. Plus this 8 feet. And we were saying, is that 68 we heard?
I heard a lot. There was a lot of 68s, but not everyone has a 68. There's an 80, there's a 50, there's a 74. So it's not exactly everyone's 68, but a lot of 68s.
Interesting. Awesome. So lots and lots of great ideas here. Great. We're making an assumption. I think going to 10 seems really reasonable to me as a starting point. I bet you if I said, like, could the stick be 9 feet? Some people would say yes. If I said, could the stick be 8 feet? I don't think people are going to be okay with that. They're going to like, no, because then you would have just put another one down.
Put a stick there.
Yeah. And you can see that it's not quite the same length. Maybe 11 feet might work. If I said 15 feet though, I bet people aren't going to feel pretty good about that. So we've got kind of a strategy here. What I'm going to do though, I want to pause, and you'll notice that I've kind of baited you here. I wouldn't have told students this, but I'm going to tell you from like the teacher move perspective. I've kind of set this up to model one of your examples. And I'm hoping that some students might latch on to this for a moment. I'm going to actually tell you how, like, the measurement of each stick. And then I want you to update your estimate, but I would like you to model it somehow. The more ways you can, the better. And then I'm hoping we might have like a brave soul, like, share what they did. We're not going to have you upload the solution for this. Like, we're not into it yet, but I do want to get some people talking here. Does that make sense, John?
Makes sense, Kyle. Let's see.
All right. That is the measurement of each stick. I want people to update this, maybe even like looking at this particular representation and try to think, like, how would this change given what we now know, and what's it going to change about this particular representation?
Right. So in the chat, try to model your thinking as best you can in the chat with how you would calculate now, knowing it's 11 feet. Normally, if you've been with us before, you know that we will get you to upload some pictures of your work. That's coming. We're not doing it here on this particular problem. We're just kind of easing into some of the thinking behind the sticks and the feet. But maybe you could try to model in your response what that might look like.
Yeah. So we'll give you a moment here.
Yeah, a couple more. We'll wait for a couple more to pop in here.
Yeah. Take a look there. What are you thinking? And I'm spending a good chunk of time, just for everyone's reference here. I'm hoping people are feeling like, so far, hopefully no one's feeling anxious or like, I'm not, equations scare me, or working with math scares me. Hopefully people are seeing this as like pretty accessible, even if it's a student who, hasn't had prior success with mathematics. And then I'm hoping we can make some connections so that we can go deeper with this thinking and this particular modeling approach that we're going to be using.
All right, so I'm seeing a couple interesting calculations here. I've got one I want to start with here, Kyle. We've got 11 plus 11 plus 11, 6 11s added together, and then plus 8. That is one way to model that thinking of adding up what the total in feet is. How far did he throw? You got it. That's from Lindsay. We've got another one, which is Ness put a couple in here, but the one that is kind of it's similar, Kyle, that I'm catching my eye, that I would, if I was in my class and I saw that solution and I saw this next one, which is actually right underneath it. It's 22 plus 22 plus 22 and then plus 8. And there's a nice connection there that you could pull out with your class if you're asking your students to say, like, how do you see the connection here? What's going on between those two solutions? I would then probably, and for folks who are with us, last week we referenced the 5 practices. I can reach it this time. The 5 practices for orchestrating productive mathematical discussions. This isn't the book that I'm referencing. This is like I guess you could call it the sequel, which is about the 5 practices in practice. It's more applicable to like modeling the 5 practices. And one of the 5 practices is selecting and sequencing student solutions. And that's what I'm doing right now. I'm looking at the solutions and going, okay, this is what I see from my students. Now I want to put them in a certain order so that I could call out that student or a group of students and say, tell us what you were thinking about that one part. And then I can call it another group that I'm sequencing them because I want to build the model up. I want to build the connections up. And notice we're going from this additive thinking. Ness has provided like this doubling idea here that also includes this additive. But then what we could do is we could move from there into 6 times 11, right? So we've got this 6 times 11 and then plus 8 in a bracket, Kyle. That's from Whitney. Whitney wrote 6 times 11 plus 8. And there's a few of those. There's a lot of those models. 6 times 11 plus 8. Michelle's got it in words, 6 jumps of 11, then add 8. So notice it's like, I could say, okay, let's go to the words, and then we're going to go to the algebraic manipulation or the algebraic representation. Or you could do the reverse. You can be like, you know what? It might be worth it to go to the algebraic representation of 6 times, it's more symbolic, 6 times 11 plus 8, and then go, okay, now let's go to the student who wrote the words. So there's a nice kind of progression that you can build when you're walking around, seeing what your strategies or students are coming up with. Now, we are taking a lot of time to kind of like elaborate and discuss all this, but this particular task could take not too long because, when you set them off just as fast as you wrote these down in the chat, your students, if they're at their whiteboards or if they're working on their surfaces or wherever they're thinking, they're also going to be coming up with some calculations pretty quickly, and you're going to be quick to see them so that you can sequence them.
Super cool. And I love how you sequence that there, John. It's kind of interesting because you and I are kind of team teaching this. What's interesting is that when you're sequencing it, I'm trying to anticipate what you're sequencing, and we're still able to kind of make some sense of this. In my own classroom, if I'm sequencing it, I might be better organized with how I structure this, right? And of course, in a classroom, a full whiteboard or blackboard might be a little bit more easy to do this as well, because I can sort of keep, my visuals here and then my symbols there. But absolutely, this part here, what we're really trying to share is this idea that this model can be really helpful for us, and it can help us scaffold to not only find answers, so use this representation as a tool, but also to help us move to a more symbolic representation. You'll notice here that we've sort of arrived at an equation based on what you were saying. And this is exactly what we would want to do in our classroom. Mind you, I'm going to guess that we didn't have to prompt you as much because, you know, you all are, you know, either have university degrees or are in teaching. So you have a lot of prior knowledge to bring to the table here. In a classroom, I might have to ask more pointed questions if I'm having a hard time sort of emerging and connecting. But again, we're not going to like let that slide. If students aren't going there, we're going to help them by essentially sharing explicitly some of those connections. So super awesome stuff. I want to keep moving this thing along here, John. Friends, take a look at how this is visual. Like when we think about this visually, and actually I just want to get this off the screen there. You'll see when we do this visually, like you can almost see the number line living in this context. So the context was selected specifically to emerge this linear model so we can get students thinking that way. It doesn't mean we're always going to solve equations with a linear model, but it does help us. So keeping this context in this linear fashion makes it really, really helpful. And of course, as you can see, a lot of your strategies we already shared, so I'm not going to spend too much time there. What I do want to do is give you the satisfaction, the opportunity to check out what really happened here, how well this particular friend of ours, this particular shot put thrower, how they did. Let's have a look and see if we were close. Let's have a look. What was that final?
Here it comes. There it is.
Look at that 74 feet in total. Nice job, everybody. In our classroom, we'd do like a one clap or something that would, you know, show some sort of celebration, or maybe, you know, if you're digital, you might have them share like their favorite, you know, their favorite animated GIF. That's appropriate. Whatever it is, to get kids excited. And then we get them, like, it's like we've baited them, John, because I don't know about you, John. Do you think we're done? Like, is this it? Like the lesson's done? What do you think?
No, we got to solve some equations, Kyle. We modeled some algebraic thinking here, or some calculations, but we're going to get into doing a little bit of the reverse right now.
Yeah, so we could get them and we give them another throw. Here's another shot put throw from another athlete. You know, we frame that context, except this time the official came and actually has a different length measuring stick. Yeah, that silly person there. You know, and we give them the opportunity to estimate. Today, we're not going to do that with you. I'm going to just tell you straight up because I want to maximize our time together here today. With you, I'm going to tell you that actually it took not 2 of these measuring sticks, not 3, not even 4. It was more than 4 measuring sticks. And we had to pace out an additional 12 feet. Now you can imagine here, this might get repetitive if we were like, all right, we're going to just tell you how long the stick is. This time I'm actually going to tell you how long the throw was. And my question is, how long is the red measuring stick? And I'm going to challenge you, how might you leverage a linear model to help you solve this problem? Let's pretend. So if you're already over there and you're already like making an equation because like you're super comfortable with that, I want you to like take that thinking, feel free to finish it, but put it to the side. And then I want you to see if you can see how a student could enter this problem and use only reasoning based on what they see on the screen in order to arrive at the length of an individual stick. I'm really curious. We're going to give you some time to work on this, and I'm hoping you'll share.
Yeah.
You'll share a photo of that work. So I'm going to get that set up as John frames this out for you.
Yeah. So Kyle's going to get that set up. You'll see a link in a moment up on his screen. So don't put anything in the chat as we kind of keep our thinking alive here. When, you know, I've had my student will put an answer in the chat, and another student's going to look at it and go, yeah, that's what I was going to do, or that's right. And then they stop thinking. We want to keep thinking alive. So hold off on your answers in the chat. Kyle's going to show you how to submit your answers. And the nice thing about using this snapshot tool that we've used, I think, on every one of our episodes, and I use it daily with my students, is that it allows a kid to submit their answer by taking their picture, right? They're thinking. You get to see that thinking instead of a text-based answer, for one. The other is that they can submit it to you or share it to you, and then it's kind of hidden until you can select and sequence which ones you want to look at. And if you're teaching remotely and you're putting it all in the chat or asking kids to put in the chat, they're going to see that, and then it's going to influence thinking. We want to like see thinking from a group of students or a collection of different students, and then be able to sequence those solutions in a way that makes this goal of yours in mind. And we'll let you in on the goal of ours in a little bit, as we're keeping it hidden from you until later. Just like we would keep it hidden from our students on what we want to do, because we want to make those connections very clear afterwards. Kyle, you're blocking the SIP 2234.
Darn, silly me, eh? I can't see
Yeah.
myself on the screen. Here, let's go with that.
There you go.
There.
So what you're going to do here, folks, is if this is new to you if you haven't been with us in the last 7 episodes, or is your first episode, then you're going to you're doing your work on your paper, or maybe you're doing it on a tablet. Wherever you're doing it, you're going to take a snapshot of that, or you're going to take a screenshot of that on maybe a device. Okay, so right now, like I would do it and take it with my phone, any sort of internet enabled device, and then you're going to go on your browser and go to joincage.com. From there, you can put the code in first. Kyle's got it up on the screen. I'll put it in the chat. And then just to streamline this, now Kyle has it set up for his students. So you'd see a whole bunch of names there. And this is easy when my students do this, because they just click their name, put their password in, and boom, they're in, and it's registered to their account and their name. However, when you are going to do it, you'll see a list of names, but right at the top, you'll see guest. Okay, so you'll see guest, click guest. And then you'll probably have to put your name in, choose a little icon, and then there it is, join as guest. Thank you, Kyle. And then once you've kind of filled that out, go ahead, join, and then you've got this home or school, doesn't matter there. Go ahead and click that button Kyle's highlighting. That's going to allow you to access your camera. You send us a picture of your work. And Kyle's going to have it. He's got it hidden on his other screen right now. And he's going to select and sequence. There they are. Whoa. There they come. They're coming in. And then we're going to have a look at them. So again, we're solving this. We're trying to figure out what is the length of a measuring stick, given the information on the screen. You're showing and leveraging this linear model that exists here, and also showing some thinking. Show us thinking on how you come up with your answer. I'm going to go silent. Kyle's going to go silent. We're going to give it a couple more minutes to let those come in.
Awesome.
All right, Kyle, what do you think? We've got some solutions on your end for ready to have a peek at.
Turning my mic on is always helpful. So there we go. I'm going to do that right now. I'm actually just firing a couple into the slides so it's a little easier to look at. They are coming in. Keep them coming, friends. Keep them coming. It is so awesome to see everybody sharing some of their thinking here with us. So I'm going to go ahead and fire a few of these in. One that I'm really, well, not just one, like there's many here I'm liking. A few came in sideways, so I'm gonna have to adjust that in a second. But I wanna grab, I'm gonna start with a visual. So John talked about the selecting and sequencing. We've talked about it many times before, this idea of selecting and sequencing of solutions and representations to kind of make things a little more scaffolded for the discussion. So I'm going to grab a few of those first. I just want to, it's good to hear what it is that we're thinking when we're selecting some of this work, so that you don't think we're just randomly grabbing stuff and randomly doing something with it. But I just want to share kind of like a bit of a progression of what you might see in terms of students working from like concrete and visual towards more abstract representations. And I'm going to go ahead and share that right now. Because yeah, I think we've got a good 3 or 4 for us to look at. So I'm going to go ahead and bring that back up here now, get my slides back. Everybody's back at it. And John, can you see this first solution there?
We are seeing it, yes.
So I'm hoping folks can see this and kind of are linking this idea that, wait a second, like down here, you can see some of the symbolic representation, but also some of this modeling. It looks like we know it's 76 feet. We knew about this 12. And either this would be something that the student would have to share with us to like let us know whether it was like, was it guess and check 16 plus 6? Like
that's what I was wondering. Like, where'd the 16 come from to begin with?
I'm wondering if
just guess and check.
I love it. Do you mind sharing like kind of like where you started? Did you start at 16 or did you start at like
I started
10?
at 10 and I knew, no, forget it. And then I thought, okay, 15, but 15 was still I thought that was too low. So I said, okay, I'll try 16. And then, yeah, I thought it worked out.
Love it. That's awesome. And you'll notice like we could have assumed that's what you did, but at the end of the day, it's quite possible that you could have done a lot of other things too. So it's always good to ask the student. So it's kind of like a bit of a guess and check, which is fantastic. So I love how you said like, no way with 10, like you got to 40, you added 12 and you're like, all right, I'm not just going to go to 11. I'm going to try, like some students might have gone to 20. And then it's like, oh, and then split the difference. You sort of went to 15 and then adjusted from there, right? You kind of compensated. So super cool. This part to me, like I'm picturing in my classroom, especially if I had whiteboards and, we're face-to-face learning, it's great to have this around the room because then you can like let students do more of a gallery walk, right? And they start walking around, have them share something they notice and wonder on each representation. Maybe it's like something you like about it or something that's clear about it, something that you're still not certain about, right? Where you can ask those students. Here's another one here, completely visual. And you can see some of the same logic, except there's kind of a scaling idea going on here. And it feels pretty clear to me, John, like, how are you interpreting this even without asking the students?
The arrows just immediately indicate that we're working backwards from 76. So you can see like right from the get-go, you're starting with 76 and you're going back the 12 that we had. Okay. And that puts us at 64. So you can see that from 64, okay, there are four sticks at 64. And then I can see the thinking here that says, okay, I'm going to cut that in half. That would make it 2 sticks. So 2 sticks cut in half gives me 32 feet to work with. And then they're like, you know what? We can cut that in half again and say, take 2 sticks, divide them up into 2, and I get 1 stick must be 16. So the length of one stick, and if you you can visually see going back up, doubling one gives you 32, or doubling one stick gives you 32, doubling two gets you back to 64, and then reverse that, go back to 12 more feet, you're back at 76. So there's a nice progression there in just the diagram itself.
And I love too, because like when you look here, it's like there's more of like an additive nature going on. Here, they're entering into multiplicative thinking by halving, right? So it's like I'm like, wait a second, 4 sticks. If I want to get to 1 stick, well, halving is convenient. Like having 64 to many students, if they're comfortable with decomposing numbers, that would probably be easier than them dividing 64 by 4, right? So again, we wouldn't do this with a calculator. We'd try to encourage students like, how are you going to get there if you don't have a calculator? If you have a calculator, rock and roll, but we want to actually try to create strategies that are going to build your fluency and your flexibility. Super cool. That's a great strategy. Check this one out as well. Do you see how, even though it's different, it's kind of the same as what we just saw? Like I might ask students like, how is this the same and how is it different from the previous solution? And what I'm hoping students would see there is like, well, in the first step, they actually subtracted the same 12 right away. Look at that. Subtracted the same 12, except I chose to divide by 4 sticks all at once instead of creating 2 groups of 2 sticks before going down to 1 group of 1 stick. So that to me is like really helpful. So there's students that are doing this work, love it. What I'm going to nudge this student to do is we're going to encourage them to show us. So prove it to us that this works, maybe on a number line or some other representation. And for a student over here, I might encourage them, what would this look like symbolically? Can you take this and show us what it looks like symbolically? Like not just to be a pain in the butt, but to help them see that they are the same. They're the same thinking, just represented differently. And then, John, the one that I think like most of us probably were taught to do in school, which is, hey, I got 4C, whatever that is. C is the length of the stick, plus 12 feet is equal to 76. Awesome. And then take away 12 on both sides, divide by 4 on both sides. I'm left with C is 16. But I think we could all agree that this is less accessible for some students right out of the gate.
Right. Yeah, so, you've got that, Kyle. And actually, I'm going to add to that before you keep going, because I ran this task in my class, and I think I could just share a couple solutions that mimic exactly those solutions. So these are from a grade 10 applied level class that we ran this equation solving. Let me just see if I can get it up on my screen here. You might have to pin me to the screen there so that I can see so everyone can see me. I think I can spotlight there. There we go. Nope, I think I just undid it. There it is. There we go. Nope, I don't know.
I just did it at the exact same time as you. I think it keeps on undoing it.
Okay, you do it. You do it.
All right, here we go. It's like we're like fighting with each other. It's fantastic.
We were. And I want to just show a couple. I only had a couple presented here, but you know what? Here's a mistake here, which is fine, right? Because you can see that same thinking that student did on that one solution. It's they started with 76, they took off the 12, and then they straight to divide by 4, that backwards thinking, but they divided wrong here to get 13 and a half. So it's like let's have a conversation about that. But then I've got 2 that use that, say, algebraic approach, which was unexpected from my kids. I would think that from my students, while we introduce solving equations, we would see more of what I just showed you, like this backwards thinking. That's if you take a person out of math class and you ask them to solve that problem, it's a solution like that one that you're going to see more often than not, right? It's like we were like, okay, let's fit this algebra into the situation, like this one. There's that one that you just showed, Kyle. This is from a student where it's like, okay, I wrote the equation, and now I'll subtract 12 on both sides, divide by 4 after. Like there's almost this mathy solution to some of these things that, say, normally just aren't natural to come up with. Right. And why I love, showcasing students' solutions like this one and like the ones that you had just showed from the folks here is that if your goal is to solve equations, and hey, by everybody, that's our goal, is to teach you how to solve equations by using like different operations and opposite operations. Like that was the learning goal intended from us from the very beginning, with that person throwing the shot. I keep calling it a put. And so that's where we wanted to go. But I love when we show this and the other types of solutions, because it's like natural to think that way. And then when you actually show kids or walk through this solution and do examples like this type, that's, you know, can be quite efficient once you get good at it, you're showing, hey, you're really doing the same thing. Like you're seeing subtracting 12 on, you're just doing it to both sides to kind of balance the balance method. You're still, there's the 76 subtract 12 right there. There's the divide by 4 right there. So there's like, I love that you can actually show kids that the things that you're naturally doing are here in math class too.
Yeah, absolutely. Absolutely, John. And, you know, I'm just kind of highlighting, like, to make this super explicit, because we want to make sure that people don't see this as an either or. It's not like, oh, okay, we're, you know, if you were in Kyle's class or in John's class, that you have to do it visual and only visual. I want students to be flexible with both, but I want to do it at their pace. And what I mean by that is, like, based on where their entry level is. So if a student's using additive thinking the whole time, it probably doesn't make sense for us to rush to symbols this way. I might have to back it up a little bit and like split up the 4 R's and make it into like an R plus an R plus an R plus an R, right? Like whatever your variable is. I'm using R for the length of the red measuring stick. But like, that's something that as the teacher, we have to be able to notice and name what students are doing so that we can help them be able to make these connections and feel confidence when they're running into other problems that they have to problem solve. So, you know, it's interesting because I saw this exact approach come out of one of our solutions that was shared here tonight. However, in my class or in my teaching experience with this task, I've never seen a student leverage the scaling. I've always seen students try to divide by 4 right away, but then many of them get stuck because I tell them you can't use a calculator. And it's like, and then they're like, done. They don't know what to do. And it's like trying to help them see, oh my gosh, the proportional nature of this task is the fact that we had this 4R is the proportional part of this linear relationship. This plus 12 is like the extra that ruins that scalability, right? That we were seeing with the hot chocolate task from a couple episodes ago, from the voting task, we could scale easily. Well, as soon as I get rid of the 12, we're back into proportion land, right? As soon as we back it up, where now it's like, it sticks and it's the length of the stick and that's it. Those are the two things tied at the hip. That's the proportional connection. Now we're good for scaling, and scaling is so powerful because I could scale up, I can scale down, I can do whatever I want in order to get me back to the place that I care about, which for us is one of these red sticks. So super cool task. This is all day one. We spent that whole time doing day one. I really want to be able to share. I'm going to share a little bit about day 2 just to give you a sample, but then the prompt I have for everybody is from day 3, I believe. And this is a 6-day unit. And it just gets more and more, I'm going to say, cognitively rich, but still accessible. I don't know, John, if you want to speak to that here as we I
think so. I'm wondering, Kyle, I know this is, I'm pulling an audible right here, but it just occurred to me, is if we want to show, like sometimes like we're doing this up on the boards and you're drawing the number line. Like I think making the connection to the number line is super, as a high school math teacher, is super rewarding. Like we've been building, and if you notice, we've been building the connections with number lines all the way back from episode 1, maybe all the way across. And we're now solving equations with number lines. And you can make it a little bit more contextual. Kyle, I don't know if you want to, like, I could bring up on my screen clotheslines. Like you could string a clothesline in your class that represents a double number, almost like a double number line. And I can just take a minute here and quickly show that activity, Kyle. I don't know if you want to pin me. I won't touch it if you pin me.
Yeah, I got you. I got your back.
Yeah. So over on my site,
wrong one.
You pinned the wrong person. No, you pinned me. There you go. So on my site, I've been solving equations with number lines for a number of years when I teach it to my 9th grade students, and I'm also my 10th grade students. But one way you can actually like add a little jazz to that also is to string up an actual clothesline in your room. So I'll just show a picture. Like here's an actual string, a double string across my room that acts as a double number line. And then what we do is we do that same kind of work that you just did on a double number line or on the number line to represent that that equation. And it's a great way to like reinforce the operations, these opposite operations that go into play when solving equations. Like you guys all subtracted 12. Well, when you put them on the double number line like this and then say, okay, well, if I got, and sometimes I treat it like a puzzle, that if I don't know this mystery number X or the length of the stick, right? So if I have 0 sticks, then I have a total length of 0. But if I have 3 sticks, what's the length that would be above it, right? And if I say, hey, that length is 15, then I could say, hey, quickly, like what's 9 sticks or 9 times the length of a stick? What's that going to be? And you're building up that proportional reasoning skills on the double number line just to get going here. We just do it with the actual strings across the room. Kids are placing them in the right spot. Then what you could do is do something like what we just did is say, okay, well, if I've got 0, clearly 0 sticks is 0 length, but if I had 3 sticks plus 4 more, and I know that that's a total length of 16 or a total of 16, then it's clear. Then when you put this next card up, when you think about it, it's like, okay, well, if I put 3x beside 3x plus 4, does it go to the right or does it go to the left of that card of 3x plus 4? Like, is it less than 3x plus 4 or is 3x more than 3x plus 4? And kids all are like, well, it's less. And then you say, well, how less? And they're like, well, it's 4 less because this one's plus 4 and that one doesn't have the plus 4. And so then you say, well, what's the card above it? And then they just done that same step about subtracting 12 like you guys just did. And so it's like, okay, they might draw that and then the same things. Then you can start mixing it up with abstract values, right? So it's like you're still doing the same procedure. It's still on a double number line. And you can say, okay, well, maybe this time if I have, where's the 5x go? 5 sticks go, well, it's to the right of 5x plus 2. And so there, what is the card above it? Well, you got to add 2. And there's that opposite operation approach coming out. And you didn't just say, hey, that's why you do the opposite operations. You would add 2 to this one right here, to the 33, and then you can divide by 5. And so then there's this 2-step solving equations coming out of the same double number line that Kyle showed you in that problem. Like, I feel like double number lines is what do we call them, Kyle? We borrowed a phrase from Kathy Fosno, which was a power tool.
It's a power tool. And Alex Lawson says it's models a model with legs, that it just keeps going. And it's just so powerful. Like both of those quotes are so important because we want to know where students are going and we don't want to give them short-term fixes. Like, this idea of like giving them a trick for something where the trick's only useful for a little while. And then it's like, then you have to go to like a different trick. Tricks aren't good, but models are powerful. And this linear model is so key.
Right. Yeah. And this is getting into what we're moving into next on day 2 of the shot put problem. But it's like, you're getting into solving equations that can be looking complex, like 4x plus 10 equals 6x plus 2. You can still use that same model to go forward into that problem, which is a problem that we're solving in 10th grade math class. So super awesome to have a model that can go from where we started back in, I think we started with like adding principle of like grade 2 all the way up to 10th grade and even into further like 11th grade, 12th grade.
Yeah, so key. That was a good call. So we will add that to the resources as well. That was a good audible. I want to let people know before we move out of day 1 that there is a consolidation prompt. It's not written on the screen, but here's the 2 visuals that students are going to be given. I'll get my head out of the way. But basically 2 more shot put throws, 2 more different measuring sticks. You got the purple, you've got the blue, and they're left And this one too, the one right here, notice that they measured too far and now they have to go back 8 feet, pace back. So what's that going to do to the equation that they're going to create and solve? Interestingly, everyone can do this. Everyone can access this through the same thinking and reasoning. But then when you go to consolidate and show the actual equation, they'll find out that it's like, 1, 2, 3, 4, 5, 6, 7 blue sticks plus or minus 8 feet is equal to 76 feet because we've gone too far. I had to go back 8 feet. So I have to take off 8 feet. And it starts to kind of make sense of why certain terms are positive and why some are negative, because the context is sort of dictating it. Day 2, you've got a series of number talks, which is awesome. But we're going to skip over that. We also give another throw, another stick. And we get students working with the 2 types of division. Remember our division episode where we talked about quotative and partitive division? This entire day, day 2, is structured around the 2 types of division and about kind of showing this idea that like students can leverage one stick and they can leverage this other stick over here. Let me hop away here. And then we ask them to kind of compare what goes on here. In particular, we give them a purple stick and then we ask them to think and kind of reflect for a moment. We say, you know, if both of these measuring sticks could measure 54 feet exactly, are there any other shot put throw lengths where this would occur? Use a model to convince us. So you can actually see up on the screen what we're hoping kids can come back with is this idea that, wait a second, there's actually like a relationship here that they will meet, like 3 purple sticks for every 2 orange sticks will maintain that proportion. It's a ratio, a 3-to-2 ratio that will continue. And students can come up with an endless number of examples. Of course, at some point, let them stop. But an endless number of examples where these sticks will meet. And you get this idea of common factors coming in and the idea that there's actually a ratio, a 3-to-2 ratio going on. That's all day 2. Day 3, though, here is the last prompt we have. And this one, I love it. I'm so happy we have time, John. I was saying before, I'm like, I'm going to rush through day 2 because I really want people to try day 3. And I wonder if this linear model can help you land on a solution. So we're going to fire another shot and we're going to put it over here, right, John? We're going to fire the shot. We're going to put it over there. We're not throwing the put. Right. And this one is actually, it's got a length of 76 feet. We already know that. We know that for certain. This is the part where with kids are like, oh, let me guess, the official's going to get another measuring stick. And I'm like, exactly. It's a green one. And he actually, or she actually measured with these green ones. And then, oh my gosh, introduce this black measuring stick to kind of throw you for a little loop. And the question we give kids is like, what's the length of a single green stick and a single black measuring stick? And all you know, my friends, is that a green plus a black measuring stick
this is my
are
favorite.
Equal to 15 feet. That is all the information we're going to share with you. We're going to go silent here. Same as before, we're going to have you upload an image of your thinking here. I want to let you know, like, in a traditional approach, like doing this symbolically, this would be a place where a lot of students will kind of fall off the rails. Like they'd be like, I don't know what to do. But I think if you use this reasoning and this visual, feel like you'll be able to come up with something interesting. So I'm going to pause. We're going to let you work on this independently.
Now, Kyle, before we go completely silent, are you wanting them to upload like we did before?
Yeah, I'm going to grab the image So that
folks,
session's still open. I'm just going to put that right on it.
Awesome. So folks, we're still kind of drawing just the same as you did last time. Throw your solutions into that same link. You know the process. Get them in there. What's your thinking here? We want the length of a single green and also a single black measuring stick. But Kyle's only showing you what you got on the screen so far. One of each. Together, though, is 15 feet. And then you've got the whole combination there adding up to 76. All right. So that's what we're working on. We're going silent. I'm really looking forward to seeing the solutions that come in on this one.
All right there, John. I'm starting to see some life
Love
in
it.
the knowledge hook
I'm
area
excited
here.
to see it. Excited to see it.
I'm hoping a few more will come out. I see a symbolic share, like it's kind of like typed. You can tell it's someone who may not have like access to a camera or isn't able to like draw it on the screens, probably stuck with like a trackpad, but is explaining their thinking pretty well. So I'm hoping that might be a solution I go to like later. I don't want to bring it up right away. I'm really hoping to get a nice visual one. Like, and by nice, it doesn't have to be a good looking visual one, just one that makes it clear what is going on here. So that one I'm gonna keep right there. Ooh, okay, here's one, some interesting logic. I think I might see a trial and error one. Again, I'm gonna have to ask. Oh, here's a visual. All right, I'm going to start with this one, partly because we're running out of time and I don't have a ton of time to, you know, go in and sequence this as nicely as I would like. Everybody's probably there going like, oh, okay, well, yeah, welcome to the online world, right? Everyone's probably feeling the same way. Let me just go like this. I want to duplicate.
I got one. Wait, hang on. Make sure I have the right. No, I have something else.
I'm wondering if I share this up on the screen, is there anyone brave out there who wants to turn on their mic and try to explain what they think this particular person was doing here? And this is a good strategy as well, so that it's not just like a show and tell session, like you're actually putting it to someone else in the room to say, have a look here. Do you agree with this? Do you disagree? Like, do you think you understand what's gone on here? Like, what has happened here? And then that person afterwards is more than welcome to share whether that's true or not, or if they have something to add. Is there anyone brave out there, John, who wants to like turn their mic on and try to explain what they see here?
Michelle's got her hand up. Michelle, take it away.
I like this a lot, better than what I tried. So they know that a green and a black are 15. So they went and they started jumps of 15. So I think they progressed up, I'm guessing. So they went 15 with a green and a black. So there were 1, 2, 3, there were 4 that could do that together. So they did 4 jumps to get to 60. And there were 2 more greens than there were black. So then they knew the distance between 60 and 76 would be 16. So a green must be worth 8.
I love it. I love
Cool.
it. And I'm wondering, and this is the one that came up first that I said, I wouldn't want to share this one first, only because if you didn't understand how to do this, it might be a little bit like scary as a student, right? Like, look at this. It's in words. It's basically what I just heard you explain. Like, we know green and black is 15. 4 green plus 4 black must be 60. Like, think of that scaling that's happening from here to here. I've got 4 times bigger, 4 times bigger. There's 2 green left over. There's that 16. Like, do you see how this makes so much more sense now that I've seen this visual and I've seen this representation? And I saw a few people doing this symbolically as well. So just because of time, I just want to share just to make sure everyone sees this thinking. It's almost like you're rearranging your sticks a little bit, right? And this is like a form of algebraic substitution that's going on. You're like going, well, wait a second. If I know that, if I know this equals that, then let's substitute it over here wherever I see it. So I'm seeing it over here and I go, oh, wow, look at these chunks. There's the 60. And then we go, well, what's left over? Well, there's 16 left. And, with whichever way you want to go, doesn't really matter. And I could take that and go, well, maybe bring it to the front of the number line if I want, depends on, how you're seeing it. And I could chop that in half. I could do it additively, or I can half 16, whatever I'm thinking. And I can tell that the green must be 8, and therefore the black must be 7. And we are good to go. But the part that I really want to be clear on to like show the value here is that typically, and I say typically because I taught it this way, like typically I would have not shown this visual because I didn't know how, to be honest. It wasn't because I didn't want to, I just didn't know how. But like this represents 6 green sticks plus 4 blue sticks, and they are equal to 76. And I have this other equation that is in proportion to, or at least I should say, has the same variables involved in them. They're not proportional equations. Otherwise they would all be one equation. But when I see this and I go, wow, I have 2 separate equations here. I have this equation. I have this second equation. How we would typically do this in a secondary classroom in a traditional sense is we would teach them this thing called substitution, right, John?
We would say, yeah, and I taught this way for a number of years. We'd say, okay, well, build your two equations, just like Kyle has just shown you on the screen. And then to solve this, like we've already seen a really elegant solution that's visual. Like you guys solve this without using any sort of algebra. But as a high school teacher, we talked about this before. You get this mentality that you're trying to help your kids as much as you can. And by doing that, you just say, I'm going to show you how to do all this. And it's like, instead of like building up thinking like we have been doing here with you. But what I used to do is say, okay, well, let me take that bottom equation there, the 1g plus the 1b, and I would solve that or isolate for one of those variables. I'd say, you know what, they're going to rearrange that equation. And I would say 1g equals 15 minus b. And then we're going to substitute that into the other equation, and that makes it messy, it makes it ugly, and there's algebra involved. And then you solve that new equation for the remaining variable. And that's a technique we teach in 10th grade math class here in Ontario. But look at this elegant solution can kind of show you this nice connection between substitution and also elimination, which is another technique. And we're kind of doing this nice substitution and solving equations in a more elegant and efficient manner. And now when I teach my students to solve systems of equations, that's what this kind of lesson kind of falls into in 10th grade math class is to look for what Kyle's doing is showing here right here. It's like, hey, if I got one of these and one of these, can I substitute that in and make my original or bigger equation simpler by using that method? It can be a nice technique that makes things more elegant, more efficient, more simple.
Now, mind you, what we're sharing too on the screen, keep in mind, like we're not asking students to share this like I'm sharing with you. I'm showing it just so the consolidation makes sense for you. And I love, John, you had said elegant, and you also use the word efficient, because one of the biggest challenges that I think we have in trying to help educators, again, it's not an either or, but to help them see that the visual is so important and the conceptual is so important, is that the conceptual allows students to come up with more elegant approaches, which is more efficient in the long run. A lot of times what we ask students to do through a procedure is only efficient in certain scenarios. Whereas there's all these other scenarios where it causes you way more havoc and way more work. I would argue with this, doing this on a number line or with relational rods even and swapping, students would come up with an answer so much faster and without a calculator. So if we're really trying to kind of, still push fundamentals, which we want that. We want students to build automaticity. We need to spend this time to ensure that students are feeling like they're able to solve these problems using reasoning and being able to actually use those reasoning skills to come up with some solutions. So we only have a couple minutes left here, John. So what do you say we wrap things up here and let's hold ourselves accountable, right?
Of course. And I hope a big idea that you got out of this, I know that there's we are talking about a 10th grade math problem here, but it can be accessible from younger grades. But I think the big idea is this, we're talking about linear equations and solving equations today, but think about the model that we have used here and stretched it from younger grades all the way up into older grades. Like they can, those vertical representations, vertical kind of tools that kind of carry forward into higher grades can be so powerful as long as we teachers decide, hey, we're going to make sure this is a priority. So Kyle, we definitely want to hold us accountable. What are the things? Give us a yes in the chat as always. Did we do the things we set out to do? Did we spark curiosity? Did we use our curiosity path slowly build you into this to get some curiosity, get some intrigue into the mathematics? Did we do that? Hopefully we did. Yes, looks like that's happening in the chat. Kyle, what else did we do?
I'm hoping that you feel better about this idea of a linear relationship. Today, we explored it mostly through equations, keeping in mind, if we take that equation and we were to put it on a graph, you're going to get a straight line. You're going to get a nice straight linear relationship graph. But I would argue like the equations are what's so scary for so many people. Do you feel like you're feeling a little more conceptually prepared for solving equations? In the chat, what are you seeing there, John? Are they saying yeah?
Yeah. Yeah, there's lots of coming in there. And then the last thing, which is the overarching theme of the whole series, all our 10-part series, is repairing, strengthening your relationship with the mathematics. We want to help you understand how the math connects. We, talked about different ways to represent solving equations here today. Hopefully that helps you think about that, and you could carry forward. I'm like, okay, you know what? Solving on a number line is different than the way I learned it when I was in school. And I think that can be helpful for my students too. So hopefully we did that. Give us a yes in the chat if that's how you feel.
Yeah,
here
let's see
today.
it. Let's see it. Oh, it's great to see an active chat. Awesome stuff. John, the last thing here that we need everybody to do before they head out tomorrow, it is registration closes for the online workshop.
Right.
So make sure you check it out if you're interested. We are giving one away right now to someone we are randomly selecting from the chat to reflect and share what is your big takeaway from today's session. And we're hoping, obviously, that you come back and hang out with us next week for episode number 8, where we're going to explore data and probability. We're going to take a pause here, let you reflect in the chat, and we'll hand it over to Michelle to kind of wrap us up here, and then we'll do the pick right after.
Yep. So go ahead and throw your biggest takeaway in the chat to be eligible. We'll choose from the chat who's going to win. Michelle, take it away, and then we'll come back and choose somebody.
Sounds good. Sounds excellent. So perfect. I'm going to share my screen again for a quick second. Thank you so much, guys. Let me share my screen. I just want to say that I love the exercise at the beginning. And one of the things that I really enjoyed is the fact that straight away people were using feet and meters. And it made me think about what happens when we confuse systems, and a couple of the catastrophes that have happened in the world when people are confusing feet and meters. I'm from Europe, so in Europe we only work in metric system. We don't use the imperial system. When I came to Canada, I got puzzled by the fact that you guys here, me also, I'm part of the Canadian tribe, and proud of being part of the Canadian tribe. But I found it confusing that you use metric as well as feet. And so one of the most famous blunder that happened is the Mars climate orbiter, when NASA was working with the Europeans, and NASA was making their calculation in feet. The Europeans were using the metric systems. And so, of course, what happened is that the orbiter crashed because they had calculated the landing in feet. The NASA people thought that the European had calculated the landing in feet, and it was in meter. And then another thing that happened actually here in Canada, and that could have been a lot more scary, is in, I think, 1983, when Air Canada had filled up a Boeing, I forgot what model of the Boeing it was.
767. I got it up on the screen. Look in the background there.
Right there. And they had filled up. They had filled up in pounds, and instead of liters. Anyway, so it was flying from Montreal to Edmonton, and it had to land in I think Red Deer or something like that, because it ran out of fuel. And just to end on a lighter note, it reminds me of a joke that we had in Europe when the French built the tunnel. The French and the Brits built the tunnel under the Channel, and people were saying, what's going to happen, because in Europe we drive on the right, and in England they drive on the left, and what's going to happen when people meet, And so the joke at the time was that Margaret Thatcher at the time had famously said, my dear compatriot, we may have to change the side of the road that we are driving on. We may have to go to the right, but let's do it progressively. Let's try with the trucks first for 2 weeks and see how it goes. So that was the joke at the time. Anyway,
I love
so I'm going to pass it back to you guys. Know that everybody has posted in the chat box. I'm going to pass it back to you guys to do that gift.
All right, John, you're up, buddy. You're going to go ahead and
all right, I'm going to scroll around here, and I'm just going to point to one after I scrolled, and I'm just going to go boom. I'm pointing at Michelle Grebe. Michelle, she says, my takeaway as a story and context is the best form of engagement. Oh, there's Michelle. I can see you in the video. Congratulations, Michelle. You are going to be joining us in the Make Math Moments That Matter online workshop. We are closing the doors for registration so we can get started on Monday. So Michelle, if you have our email address, Kyle, maybe we can put it in the chat.
Yep.
And then you can email us, and then we will send you information on how you can register and take part.
Awesome stuff, my friends. We had a blast as per usual.
Take care, everybody.
Thanks so much. And hopefully we'll see you next week, everybody.
Yeah, fantastic, guys. 3 more sessions to go. So we have 3 in February, and we hopefully will see you all next week. And I won't make it any longer because we are a bit late today. But thanks so much for this fantastic presentation, and I hope to see you next week. And congratulations to Michelle. It had to fall on her eventually because she has been there for every single
Nice.
webinar.
Camera
So
on,
it had
ready
to
to
fall.
rock.
Yeah, exactly.
Right.
Love
Right.
it.
Thank you.
Awesome stuff. Thanks, everybody. Take care. I'll see you next week.
Good
See
night,
everyone.
everybody.
Take care.
Bye.